Hey, what's up guys? This is Akshay from AS Learning, and today in this video we'll be seeing how to use FUYU 8 billion parameter model via Python. Okay, so for accessing FUYU, here I'm connected to Tesla T4 GPU of uh, on Google Colab. Okay, and if you wanna connect to GPU, all you need to do is just open Google Colab and go to runtime, then change runtime type and select your required hardware accelerator. Okay, A100 and V100 are not available. They are faster than Tesla T4. You have your CPU and Google's TPU. Here I'm connected to Tesla T4. Okay, I think for accessing A100 and V100 you need to upgrade to Google Colab Pro. Okay, and they are faster than T4, and most of the models in the world currently are trained on them only. Okay, so here I'm connected to Tesla T4. Okay, I am getting a system RAM of 12.7 GB, and the GPU RAM I'm getting is of 16 GB, which is not currently visible here. The disk is of 78.2 GB. Okay, now if you're wondering if I'm connected to a GPU, okay, how I'm seeing the system RAM, that's the question. It's coming in your mind. So it is because we are not connected to a physical GPU altogether. We are connected to a virtual machine, okay, which is being provided to us by Google's cloud provider services. Okay, and that virtual machine has its own system RAM also and GPU RAM also. Okay, so now we'll start with the installation. Okay, we'll go step by step. We'll see each parameter slowly, step by step. Okay, it will be a long video, but it will be very much informative. So just stick till the last. Okay, so in the first cell here, I am installing the required packages, that is transformers, bits and bytes, and accelerate. Okay, so let me do it. Okay, now if you must be thinking why I have not done pip install transformers, right? But why just git plus https github hugging face transformers.git? The reason for that is, here see, currently the latest version of transformers which has been released is 4.34.1. okay, right now on 24 October. Okay, it is 24 October 2023. The latest version right now is 4.34.1, but FUYU has not been released in that version. The support for FUYU is not there. Hence, I am installing transformers from the main branch. Okay, we are using bits and bytes for loading the model into 4-bit quantized version. Okay, and we are using accelerate for taking help of, for we here are using a sharded model, and we want distributed computing functionality with us. So accelerate comes handy there when you want a distributed environment. Okay, so this is, I'm done with the installation. Okay, I am doing it in a quiet mode with less verbose, hence -q. Okay, now in the next cell, I am importing my required packages. I am importing requests because the first image which we would be testing is a standard image which is there on GitHub. Okay, so now not GitHub, the Hugging Face. Okay, so we would be firing a get API for fetching that image. Then we have okay. Meanwhile, we will see. Okay, let me do it again. I want to show you how the RAM and disk are impacted by each action. Okay, let me disconnect and delete the runtime. We'll be tracking it. Okay, so here let me connect to T4 again. Now once I'm connected to T4, as you can see that my system RAM is just 0.8 GB. GPU RAM, it is allocated to a 16 GB, but nothing is used, and disk 27 GB is being acquired, 78.2 GB it is available to us. Let me do the installation again, and we will be tracking the disk space and the system RAM together with it. Okay, now this should increase the space a bit because we are installing 3 packages. Okay, and even some RAM is being used here, system RAM is being used. As you can see that the disk is somewhat increasing here. Okay, Next, okay, it should be done now. Let me zoom this a bit. Okay, this should be good. Now here I'm importing my required packages. Okay, keep a track of the RAM and the disk space here. Okay. Okay, so let's discuss the packages here. I will be importing request. Request will be used. Request will be used for. It is just to get the required standard test image provided to us by Hugging Face and FUYU. Okay, and then from transformers we are importing FUYU for casual LM for loading a model. We have auto processor for tokenizing the text prompt and the image, and providing and to pre-process these two things into a format which will be appropriate for FUYU. Okay, so with the help of this auto tokenizers we will be passing a text prompt and the image, and we will be converting them into such tensor dictionary format which will be suitable for FUYU. Okay, it will be input IDs, image patches, and image patches indices. We will be seeing about them later on. Okay, bits and bytes is for model quantization. Okay, image is for when I'll be separately loading an image here, then image will come handy. And torch. This is my model ID. Okay. Model ID here I have here it is a sharded version of FUYU 8-bit. Okay, now how sharded version of FUYU 8-bit is different from normal FUYU 8-bit, we'll come to that later. Okay, and in this auto processor, I am passing the model ID and I'm loading the required processor for FUYU. Okay, so now let's discuss what is sharded model and how it is different from normal model. Okay, so what happens is sharding we can do of data sharding also, and we can do model sharding. So what sharding does is it breaks the big model into small chunks. In this case, it is done into 11 shards. Okay, we will be seeing it later on how it is 11 and all. It's a .bin file which has been broken down into 11 shards. Okay, and then we can take help of because it's a sharded version, then we can take help of distributed computing and all these things. Okay, it makes helpful to run such big models on less compute units. Okay, and the reason why a sharded model is used is because if you try to load the entire FUYU which is not sharded, you would require a lot of RAM. Okay, as per my read, you need at least 24 GB of GPU RAM, okay, to load the entire FUYU, which is a non-sharded model. But because it's a sharded one, we are able to load it into 16 GB. Okay, the way it loads shard by shard. It does whatever work which we need to do on one shard. The shard is offloaded to the disk. Okay, and then the another shard is loaded again. In this way it works. Okay, how exactly in inference it comes handy, we'll see it later. Okay, so here I have downloaded the tokenizer, the required JSON files for processor, tokenizer config, and special tokens map.json. Okay, special tokens are start and the start token, end token, separators, and these things. Okay, so here we can see that my disk is not much occupied, only 0.5 GB is increased here. GPU is not touched at all. RAM has increased by at least 1 GB. Okay, because this variable is somewhat loaded there now, this processor variable and all. Okay, and also model ID. Now what we'll be doing is we will be loading our FUYU into 4-bit quantized version. Now what is this 4-bit quantized version? We are lowering down the precision of the weights and the activations which are there in FUYU. Okay, we want it in 4-bit, and the reason for that is we want to make it compatible with our computing unit of 16 GB GPU RAM which we have got. Okay, if you load the entire FUYU without quantization, you might get out of memory errors, which I have got. I have got out of memory errors, hence I am using a sharded memory. Okay, sorry, a sharded model. Okay, If you load the entire FUYU, you will 100% get a out of memory error if you are accessing it on a 16 GB GPU RAM. If you want to load the entire model, you need to do it on a 24 GB at least. Okay. Now, as you can see here, so this tracker which you are seeing is the tracker of the shards. Okay. So here the first shard is being downloaded. All the shards are roughly of 2 GB. Okay. And as you can see, with each download, the disk space will go up because the shards are being downloaded on a disk. Okay. GPU RAM is not touched at all. It is 15 GB RAM which we have got. Okay. Now step by step the shards are being downloaded, and once the shards are downloaded, then the checkpoints of the shards will be loaded, okay, into our GPU and system RAM. Okay. But here I have passed the quantization configuration here as a parameter. Okay. And here I have kept the compute D type as torch float 16. For some reason, I've seen people keep it torch float B16 or 16. Okay, these two. For why? What is the real reason why they keep it there? The reason for that is that with keeping the compute D type as float 16, the model gives good performance. Okay. But why with 16 it does, even I right now don't have the answer for it. Okay. Yeah, if you know why it works, please comment down in the video. Okay, that would be something which you will I'll learn. Okay. So here, while the shards are being downloaded, we will be seeing how this sharded model will be used into model inferences. We will be passing our text prompt and the image. Okay, and how it will work will be, I'll be taking the first shard, not I, the system will take the first shard. Okay, it will compute the required activations and the output as compared to that shard model. Okay, now when the second it would be offloaded, then the second shard would be brought up. To that second shard, the first activation output would be given as an input. In this way, sequence by sequence, all the 11 shards would be we would be done with, and we would be having our final output of the inference from all the shards step by step. So the first shard output goes as an input to second shard, then the second shard's input goes to the third. In this way, sequence by sequence, the shard model will be loaded into the GPU memory. We'll be having in this way, we will be having a final output. So the entire model is not being used here. Shard by shard, we are using it. Hence, we are able to run this model on a 16 GB GPU RAM. Okay. Actually, it uses just 11 GB. Okay. So we get done into 11 GB only. Okay. So here you are seeing that the disk space is going up. The reason for that, all the shards are being downloaded. All the shards you can see are roughly of 2 GB. So if I do 11 into 2, that is roughly 22 GB. Hence, I told that for running the entire FUYU model, you at least need 24 GB of GPU RAM, because the model itself is of 22 GB. Right. So here the shards are downloaded. Now you will see that there is a spike into system RAM and GPU RAM, because now the shard checkpoints are being loaded. Yeah, as I was saying that a system RAM there's a spike, and even in the GPU RAM you will be seeing a spike. Okay. So slowly the checkpoints or shards are being loaded into the RAM. Okay. So meanwhile it happens, we'll be seeing other things. So here what I've done is this is the test image URL, okay, of bus. We can see it's a blue bus on a clear daylight with a destination of north and west. Okay. So using the request get API, okay, I have fetched the image and I've got the raw image here. Okay, nothing different. So this is my image and this is my text prompt. I'm asking him generate him a Coco style caption. Okay, so if you don't know, FUYU is very good into image captioning and visual question answering. Okay, so if you want to know how exactly FUYU is different from, let's say, Palmy, Lalava 1.5, and on architecture level how it is different, I would recommend you please check this video. Okay, on FUYU, which is my previous video where I explained how FUYU is different from other models, and also we saw its demo on Hugging Face Spaces. Okay, and I think it's still loading only. So meanwhile, what we'll do is we have a text prompt here. So I'm telling, I will be telling FUYU that generate me a Coco style caption, right? Generate me a Coco style caption. Coco is a very popular data set. Okay, it's a very popular data set. Okay, and I'll be telling him generate a Coco style caption for this image. Okay, now here all my checkpoints are loaded into memory. As you can see that 7.4 GB got acquired into GPU RAM and 4 GB was acquired into system RAM. Okay, now let me have my text prompt here. Now what I'll be doing is I will be, what is saying is raw image is not defined. Why raw image is not defined? Okay, I'll run it again. Raw image is defined, and now I'll be passing my text prompt and my raw image to my processor object of the auto processor class. Okay. Now in this, what happens is these two inputs of text prompts and the raw image are broken down into image patches, the indices of those patches, and the input IDs. Okay. And then these three tensors are being sent to the model. Okay. Yeah. So as we can see here in the below cell, this model inputs dot items is a dictionary which contains three tensors: image patches tensors, image patches indices tensors, okay, and the input IDs. So in this format, the processor breaks down the input of text prompt and the raw image. Okay, there's just a check here whether if it's a not, if any of the value is not an integer, just do a casting into float16. Okay, and then these three tensors are passed as a keyword argument to my model.generate function. Here I've kept the max new tokens as 50. Okay, so it will be generating 50 max new tokens for you. Okay, now what is a token? Token is not a character or a word. It just think of token like it can be some pieces of characters. Okay, it can be a word also which can be meaningful. It can be a chopped pieces of characters also. That is how our tokens are. Okay, and once they are passed to model.generate, I am getting my generation output, and then I am decoding it back because processor encoded it. Now we are batch decoding it again. Okay, and I have kept the skip special tokens as true. Now skip special tokens means the start token and token separator, I want it to be gone. Okay, and here I've printed my generation text. Now here you must be seeing what is this speaker new line coming, right? So before interpreting this, let's take a simple example where these things are not coming, and we'll come back to those later on. I think this is done there. As you can see that GPU RAM has gone up now, right? 10.3 GB is what I needed here. Okay, I'll close this now. So the question I asked was generate a Coco style caption for this image. Okay, and the answer I got is a blue bus parked on the side of the road. Good one, right? And as you can see that here I am batch decoding only the last 7 tokens which were generated, right? Now the thing here is that FUYU works in an auto-regressive way. Okay, let's say you gave 2 tokens, it came up with third, then the third is coming back as the input and it is coming with the fourth one as the prediction. Step by step it is generating. In this way, we told him to keep the max new token as 7. So the last 7 tokens, right? Last 7 tokens will be my output for the question asked. Okay. Now here then I'm decoding the last 7 token only. Okay. Now let's say here I kept it, let's say 20. Now in this 20, we will be seeing speaker, new line, and also the text prompt which was passed. Okay, in 20 the text prompt, the new line speaker didn't came. Let me increase it to 30 or maybe 40. I want to show the new lines also. So as you can see, speaker, then in between you will see a new line somewhere, new line. Okay, here in between speaker the new line didn't came. Okay, then we have a text prompt, generate a Coco style caption, and then we have you can think of this as a separator only. After this separator you will be having the answer to your asked question. Okay, this was my text prompt and this is my image. Okay, so this speaker is nothing but my image patches, and this new line is the separation between those image patches. Let me show you more. I want to show you the separation between the image patches. Now, what is this? Why this new line and why this image patches? This is because as you can see, new line, speaker, in between we have a new line. So this new line is separating the two image patches here. Okay, so my image patches are going, my text prompt is going, and finally I'm getting the output in an auto regressive way. Right, now the thing is, why in this fashion? The reason for that is FUYU works in a raster scan order way. Okay, now what is raster scan, and like how, like why position embeddings are not used here, and what are the advantages and all? For that you will have to check my previous video on FUYU. There I've explained it. Okay, now we have now we saw the generation of the output. These are the tensors. Okay, the input ID tensors, image patch tensors, and the image patch analysis tensors. This for the last 7. So these, you can see that all the tokens are different, and individually if you want to see the tokens, as you can see there is. Let me see whether I can see the broken tokens here. Let's do here. I think broken tokens won't come, but let's see whether it is that 11791126298. Let's see whether I see any broken. As you can see here, this token here 126294 is a combination of space and words. These two are individual words only. Yeah, so as I was saying, sometimes you will also see broken, like you will see, for example, on the SI broken down and then DI off is into some another token. Okay. Now this is the next question which I asked, like a visual question answering prompt. This was like an image caption. Here I've asked what is the destination return on the bus. So this is something like an OCR, because he will have to perform an OCR act here. And here we can see that the destination written on the bus is Northern West and Northern West 61C. It is doing good. Yeah, so next we'll be seeing is I will be uploading an image on Google Colab, and then I'll be asking questions on that image. So here I uploaded Coca-Cola.png image. Okay, this is how the image looks like, and now I'm asking him what type of bottle is depicted in the image. Okay, so it's a Coca-Cola bottle, and as you can see that the output which I'm getting here is Coca-Cola bottle. Okay, so in this way we saw how to do question answering, visual question answering and image captioning on the upload image, and as well as we saw it on the standard image. Okay, then we saw how model works in the sharded way, how model inference is working in the sharded way. And yeah, this is what I had in FUYU. Okay, if you want to know more about FUYU, check my first video on how internally it is working and what are the benchmarks and how it is different from other models, the Hugging Face space. Okay, and if you want to use it using Python, then you can do it in this way. Okay, so if you learn anything new, do give it a like, share it with your friends, and stay tuned to AS for more such amazing tech stuff. Take care, peace out.